Hey everyone, just kicking off the stream here. I hope you all having a good evening out there in the States, Europe, sometime around, I don't know, midnight. What's going on over there? Who knows anything about time zones in Europe? I sure don't. It's morning out here in Japan, almost noon actually. So I'm starting a little later than normal, but I hope you all are awake enough to watch and follow along with, making launching attacks, juggling. That's what we're going to do today. Anyway, I'm going to let people fall in a bit, give them a little bit of time. And yeah, we can just chat. We were chatting a little bit about recent fighting games and how much information is out there, how to play them, how beginners can get like a leg up really quickly. Yeah, and for me, the fun in fighting games is finding the strategies, right? Like spending the time yourself to dig in and really like chew on what's there and figuring out like, okay, I keep getting beat by this thing, and how do I deal with it? And it's kind of, I'm not going to say having the information is a bad thing, but for me personally, it feels like, well, then I have to go dig through all these videos to find the right information, because there's a mix of good and bad. And it's always up to me to not do that, right? I could have my fun potentially by just ignoring that and figuring out the stuff for myself. But there's always a nagging feeling that I'm wasting my time if I don't go look, because there's so many things in fighting games you just get crushed by at the very beginning. They could easily be defeated. Things that everybody knows how to deal with unless you play the game. So that's like the part you really want to get past, and then maybe you can start chewing on the more chunky bits of game strategy. Anyway, I hope my audio levels here are good today. I've had issues in the past with the previous videos where I thought my mic was a little low, so I'm going to do my best to try to make it very clear going forward, so that my voice is clear enough when explaining things. Okay. Sweet. Looks like we got a few people here. Hope you're all doing good. Very mysterious music. Okay, I think I'm just going to kick off with what we're going to do today. Give me a second here. Alrighty. Where are my notes? Dig, comments, debug. Here we go. Alrighty. Just have a rough outline here for y'all. Just going to cover like launch attacks, let's say launching attacks, which means we're going to have like a launch property, which is the thing that when assigned to an attack makes it so the character would go into a launch reaction, sending them into the air, so that there's going to have to be juggle physics or launch physics. That means also the attack needs some kind of wise velocity to it to apply to the character being hit, so that we can control how high they go. We're going to have gravity as well, right? Maybe hit gravity. Some games have a default gravity. Some games let you override the gravity. Let's just say default. Let's have a default gravity for today. Okay, default launch gravity, right? And we're going to have to have like a knockback, which will just be an X velocity applied. And then we're going to have to turn off friction during the air. Otherwise, the character will just kind of go up and slow down and fall straight down, which might be fine. We may actually want a kind of a friction just to modify the feel of our juggles, but that depends on the game design. Really it depends on what you want. I hope that stuff we're going to cover is pretty clear. And then obviously we have to implement the reaction itself, which is just going to be a state in our state machine that controls what the character does when they're in the air being hit. And eventually, maybe today we'll get to juggling, which means while you're in the air, you also can get hit, and that same juggling state will repeat. For our game, we'll make it very simple. There's going to be no getting out of the air state for now. Maybe we'll cover that in the future, like hit stun deterioration, that kind of stuff. I don't know if we'll do things like I don't know if I introduced juggling points or anything like that. It's not. I think it's beyond the scope of what I want to do here. Maybe it's more of the kind of like exercise for the reader kind of thing. I don't know. The games I do typically, I'll do kind of hit stun deterioration or something, or some kind of rule set that does that. Not like juggle points or stuff like that. I think some Street Fighter games do have that, like a limited number of hits or something. We might, but I will probably do air recovery though eventually. Yeah. Hope that's all clear. So the first thing we need to do is add the actual launch properties to our hits, right? So I believe that was in what, our character data? Did we have a hit property? Action properties, so action properties, and then each hit had properties, right? We had pushback hitbox, attack hitbox group. What is hitbox group? I thought we had hit properties. Do we not have hit properties? Oh wow, I thought I actually had some hit properties so far, but man, it's been so long since I worked on this. I honestly have forgotten. So I guess the first thing we're gonna have to do is add hit properties. Yeah, so I think right now when we do a hit, right, we have a reaction system. We have hit stun and stuff, right? But hit stun, what does hit stun and hit stop come from? We do apply it. Let's see where we apply hit stop. And honestly, I have to remind myself of this stuff so often, you know, because this is a lot of complexity, and it's okay to remind yourself. This stuff is hard. Okay, let's go through here and look. Okay, so we have our collision system. We have a game. Oh yeah, so when we generate a hit event, we have this structure that stores all the hit properties. We have like hit stun and guard stun and hit stop and knockback. Okay, that's in our hit event. So first thing we need to do is update hit events, right? Okay, where's our hit event? Well, probably a lot of stuff in is calling hit events. So hit events equals, where do we got the hit events at? Our structure. We're reading it here a lot. Here we go. Here's our hit event struct. Okay, so yeah, we have attacker, defender, hit stun, guard stun, hit stop, knockback. So we're going to start from the hit event, go back, add it to our action properties. Because currently you don't store any hit properties in the action data itself. We're going to have to do that. Just haven't got around to it. I think I had it on my list before and just somehow overlooked it. And you know, right now we're just setting kind of like default hit properties when we generate the hit event. So we're just going to say first, is it launch attack? Is launch? Let's say it's is launch and make that a bool. And then we're going to have a launch velocity. So launch velocity. Let's say launch velocity y. Let's do launch velocity x. That needs to be at 32. Or you could call it air knockback or something. But sometimes we want to separate the launch properties from this. But maybe thinking about it, simple is better for now. So let's just stick with adding our launch velocity y. And yeah, we got that. Not int32, it's i32. Alrighty, so when it is a launch, we'll apply this launch velocity. Otherwise, this will not be applied. Now, you could have a decision here where you have like a separate structure for like a launch properties, you know, and we could like incorporate that here, and we only need to add the properties to the launch structure and only use the launch structure when this is set to a launch. But for now, we'll stick with this, keep it simple. And if this ever got too big, we might want to consider breaking out to different struct. Okay, I'm going to turn off the music here. It might be a little too loud and distracting, so yeah. Okay. Here we go. Okay, we have our hit structure. We need to go back to where we're using it. Where was that at? Oh yeah, we just search for hit stop to see this thing do. And we apply it here. And we're just going to like make it a launch for now. Every attack is going to be a launch, and every attack is going to have some kind of launch properties for now, just for testing purposes. And then we'll go through and make this more general. Sometimes I like to start with a solid example, a concrete example, and then I'll become more general. Okay, and I think it was like launch velocity y. I think that was it. Just same insane number for now. That's probably not actually an insane number, but we'll just apply it to make sure the build works here, because I think those are the right properties. Unfortunately, the IDE doesn't really give me a lot of with this language server. It doesn't give me a lot of autocomplete. All right, okay, it's fine. So this shouldn't affect what we have now because we don't actually have a launch state. All right, so we have the basic properties in there. Now we actually need to implement a launch state in our common states, right? So we have a reaction state, right? And now we have to go through and add a launch state. We could add the code in the reaction itself, but that would add a lot of complexity. And and one thing we could potentially do is have like a variable on the reaction component that says, okay, we're currently launched and launched. But ultimately, when you start separating all these things, it reduces complexity per state because you don't have a bunch of different exceptions, right? For every potential thing that could happen. Okay, so we can call it just launch reaction, right? Or launched reaction, right? Launched reaction. Launch reaction, launch reaction. Let's call it launch reaction. Let's keep it simpler. All right, launch reaction. Okay, it's called launch reaction. And the first thing we have to do on start is apply the physics, right? Because we're going to apply a velocity and initiate the gravity in a similar way to jump. Because it's similar to jump, let's go check out what jump looks like. So at the beginning of jump, we have these kind of physics things. And we set a forward speed. And on update, we need to handle collision on the ground. So actually, it might make sense to start with the jump code, right? But maybe we should hook up the launch property first and then deal with the physics later. We don't want to put the cart before the horse. So let's go ahead and do that. So let's see where all our reaction stuff is set up. Okay, since this is going to be a common hit, we're going to have to set up give it a name. We're going to have to add it to the enum list of actions. And I forgot exactly where all that is. Is it up here at the top? No, it's not here. Where is that stuff stored? Was it character data? Reaction system? I don't think it's reaction system, is it? Bleh. Okay. Let's action type. Is it action types? No, action or common actions? I don't know. Honestly, I forgot. It happens. It happens. So yeah. Let's yep. I'm just gonna do our code real quick, see what I can remember. Common. Is it in common? No, common. Character data. No, I said that before. Right? It's not character data. But we included in the character data. No, we did not. Game state. I don't think it'd be in the game state. Oh, here we go. It's in the state machine. There we go. So we're gonna change special. We're gonna add a launch reaction. Honestly, it should be next to normal reactions. Launch reaction. Okay, we have it there. So we have to go through all this stuff and like again, we have this boilerplate stuff we have to go through. It's kind of annoying to do it, but it's got to be done. So where do we actually use the combat state stuff? I thought we had. Don't have to do anything boilerplate wise for setting this up. Okay, I think this part is fine. Oh, the problem is that's one kind of issue with Zig. It's kind of nice sometimes not to actually have to write out the full name of an enum, like combat ID, state ID dot reaction or whatever. But the issue is then it becomes like less searchable, right? Okay, so we're gonna have to do, I'm gonna go through and try to copy all the boilerplate for our existing reaction, right? So we have the reaction callbacks. I'm gonna go ahead and just make, at some point I really need to generalize this stuff. So I don't have to do this every time I add a new state. Yeah, so that's gonna be launch reactions name, and launch reaction is the actual struct that we're using. Properly capitalize that reaction name. Common states, yeah, we have to go through here. And that's it. And then we have to add it to our list of things. I wish I was better with the keyboard shortcuts here, so I don't have to keep using my mouse. Okay. Okay, so we updated there. That looks good. What other boilerplate we might have? We have this boilerplate. So we have the with reaction components. That's fine. It's fine. It's fine. That's not what we're actually looking for. We have the transition to state stuff. So this is actually going to be where we pick to do the launch attack. So we either go to guard reaction or get a or if it wasn't guarded, if the action had a launch attack, then we'll do something different. So let's say if, where was it at? The game state hit events. Game state dot hit event is launch. Oh, event dot is launch. If this is launch, what's the problem there? Oh, yeah. So if it is a launch, we won't go into the normal reaction. We'll go into the launch reaction. Simple enough, right? So launch reaction. Okay. Hit stun is still applied. Right, we're gonna. Right now, it won't affect the launch itself, but we'll still apply it. Okay. Maybe we could generalize this, like, instead of doing this, we always kind of want hit stun to be applied, right? So let's say if, where was it? Hit event. Oh yeah, hit event is launch. Then we could do this, else this, right? So yeah, that goes there. Else. All right, there we go. So we go in the launch reaction once launch, otherwise we go normal reaction. That's kind of expectation. Though, just kind of a preview, it's going to go on. We're going to have to change this for when they're in the air because we don't want them to go to a normal reaction when they're in the air. But that's when we get to juggles. So we'll have to revisit that. Okay, so that's done. So we have the transition set up when it's a launch. We have the boilerplate for the reaction. So let's make sure the reaction actually executes when we attack. That's important. So let's go back to our common states here. Let's print out the name of the launch reaction when it starts so we know it happens. Yep. Okay. So that's good. That's good. So let's run the game, see if there's any kind of compile errors. Okay. Making good progress already, I think. So, all right. Can we see the attack here? So they went onto normal reaction. So what happened? We got normal reaction. We didn't get launch. So what happened? What did we miss? Well, one thing we can do is check the debugger real quick in the reaction system and see we actually, what do we hit here? So let's step over. Okay, it did try to transition to launch reaction. So what happened? Do we not set that up properly? Properly. Let's double check our work real quick. Actually, probably the easiest thing to do is look at the changes. This is sometimes the best way to go about it. So that works. We know that part works with setting up the actual being a launch. With the launch reaction states, oh, there we go. I did the wrong callbacks. That's the problem. So I can fix that real quick. Probably good now. Let's get the game running. Let's stop the debugger, get the game running, and we should be good. We should be good. Okay. Yeah. Okay. Yep. And you can see launch reaction executes. No issue there. So now we can work on the physics of it. And our starting point is going to be a jump, right? We're going to use the jump physics, which means we're going to apply initial velocity upwards and then gravity downwards in the same way. So that's pretty simple. Let's go to our jump, right? And this is copy the initialization code. So I think most of this is what we want. Only initialize jump velocity when on the ground. Okay. We won't necessarily need that part, but yeah, for the launch. But we'll do that. And we'll also continue to flip the face of the opponent on hit. This is kind of standard thing you do in most fighting games. You don't have to do that, but we'll do that. And let's not do that. We actually need the hit properties, but we'll go through and add that later. We don't actually have access to the hit properties right now, I believe. We might Actually, let me look at that real quick. Do we store the hit properties on the hit event from the hit event? I don't remember us storing it. Okay, so we do have hit properties, right? So we have knockback. So we'll have to assign those here. It's in the stats. Oh no, it's in the reaction component. Good. So open our component thing, reaction component. So we have hit stun, guard stun, hit stop, knockback, attack. So we want our launch velocity, right? So launch velocity equals, say, is launch velocity y is 0. I know I have inconsistent naming for capitalization for this stuff. I forgot. I think at some point I wanted to follow the Zig standard, and then like I started like coding like I normally would in like under Unreal, because Unreal has its own coding standard. You try to be consistent with that, and then turns out Zig standard is a little different. I still don't know where I fall on that. Anyway, that's neither here nor there. Let's continue. Okay, so we'll need to assign in the reaction system that property. So let's do it right under knockback. The truth is we don't really even need to update this unless it actually is a launch, right? So that's one thing we could do. We can say, hey, okay, if it's launch, we'll update this value. And maybe in other cases we'll actually want to update it, but yeah. Also, I just want to point out we have this kind of like pipeline that we generate a hit event, then we copy each individual property from the hit event. It gives us a little bit more flexibility on how we apply the attack properties to our reactions. There might be a reason to do things a little differently despite maybe what the hit property, because you could just copy the entire struct from the hit property to, say, the character's reaction component to be used when you're executing the state for a reaction. But there might be reasons to modify it along the way. So for now, we're just copying individual parameters or properties. Yep. Maybe there's a formatter linter that conforms it to Zig standards. I think there is, but I think the issue I had with that is it changed a lot. And I didn't want my change list to be like, I don't know, kind of dirtied by all the, or like kind of corrupted. Not corrupted. I don't know what's the right word I'm looking for. Anyway, yeah, I don't want to have giant change list of those things, so I haven't done it yet, anything like that. I've always struggled with a lot of formatters and linters. They kind of get in your way a lot of the time. So, yeah. Alrighty. So that is support. Oh, we still need to go to the common states and support that actual velocity. So that should be in our component. So context dot reaction component dot launch velocity y. Okay, there we go. So we've applied the launch velocity y. We actually want to apply the knockback as well. So we'll choose to set the forward speed for the knockback. And in fact, I forgot, in our reaction, we don't actually have a knockback setting. I mean, we have a knockback, but yeah, I forgot we don't apply the physics at the start of the reaction. I think we applied it in the reaction system. Maybe. I don't remember. I actually don't know where we're actually applying the knockback. Oh well. Well, for now, ignore all this problem stuff. We'll just say, hey, we're applying knockback here in the launch reaction. But we should confirm everything bit by bit by bit, step by step by step. You know, we don't want to do too much at once. So, as you see, we also have the gravity. So we're just going to assume the gravity is going to be the same as jump for now. Acceleration y pointing downwards, and we ignore this forward speed. Oh, okay. So this is for the jump. So we don't need this for now. Let's just comment that out. Well, we don't even comment that out. I'm going to get rid of this entirely, but we're going to reuse this forward speed probably for the knockback. Okay, let's get the game running. Oh no, errors. Use undeclared he event. So that's in the reaction system. He event. Where's the he event? Nope, that should be hit event. I don't even know how I did that. I got another error. There's a hit event here, isn't there? Oh. They should have a launch velocity, right? Launch velocity. Did I run name? Oh, again. Ah, hold on. Did I did I capitalize it? I did capitalize it, didn't I? That should be correct, right? I think I made it lowercase for that struct. No, was that not the case? No member name launch velocity in the game hit event. Okay, let me go to the hit events. Go to definition, go to hit events. Double check. I named it like that, so launch velocity. There we go. Okay. I'm not the best with consistency in naming and capitalization. I apologize. No number name is launch true. What? What did I do? Collision system. Or is that 101? There is no launch velocity Y. There is no launch velocity Y in. You serious? Oh, yes, serious. I forgot the Y. Okay, attack. And they're gone. Oh, you see how like the velocity up was left over? Oh wow. Something weird is going on here. Let's lower that velocity upwards. Actually, let's copy what the jump is because that's something we know physics wise works in our game simulation. So jump equals what? And what's the jump velocity? It's 20,000. So let's go check our collision code. So I think that's where we set this. Maybe it's too low. I don't know. Maybe I left out something important. I left something out important. Oh, I forgot. We forgot something very critical. When I say we, I apologize. I mean me. We got the test character data, so we need to copy the reaction data because we don't really have any collision boxes or anything like that, right? It just this is missing, so yeah, we need to copy it and paste it and make this the launch reaction. And we'll just make the same duration. Actually, launch reaction, let's just make it go a ridiculously long amount of time because it's going to be interrupted when it hits the ground. Effectively, it's a looping thing. Yeah. Okay, so that's fine. That's fine. It's fine. We're just using the animation. Because we don't actually have a hit animation for it yet. We could add that in the future pretty easily. But it's called launch reaction, right? Okay, there we go. Yay. You see how it goes? And you see how the friction is being applied? They're going backwards a little bit, but then they immediately slow down and go up. Because the ground friction is being applied. We want to disable that friction. The jump should have had a friction disabling thing. Does the jump not have it? Oops, I don't want to change that. We didn't turn off the friction here. Do we on update? No. Why is the friction not being disabled on jump? Well, actually the truth is we're not even applying this forward speed, so it's probably not even friction. It's probably this reaction physics we have. So let's go open the physics system real quick. Again, it's been a while. Oh, I think it's where's the physics system? Physics system. Ooh. Or is it in the reaction processor? Ooh, that's not where I want to go. How I got there? Not processor. I keep calling processor. Processor is the name of these kind of things in Unreal's new mass entity system. So I keep saying processor, but no, we call it system in our architecture here. Okay. So this is executing everything. If there's a hit, handle the hits. Otherwise, we have a hit stop handling, hit stun handling thing, which handles going back to idle when the hit stun is done. But we actually don't want to go back to idle when hit stun is done. So I'm glad I looked at this. Or one thing we could do is we can double back and say that we give it a lot of hit stun and they recover in the air. We kind of automatically get recovery in the air if we do this, but the problem is, look, well, actually, you know what? Let's just let the bugs be bugs and ignore this for now. And it's much better to see the bug or see the unintended behavior and correct it in context. So I'll just leave that as I'm getting too far ahead, as I often do, because I've done this many times. So I can kind of see the problems. But it's better for me to explain them step by step for these videos. That's kind of the point. It's to keep that knowledge somewhere before I forget it. Okay. Anywho, where are we going? Yeah, so I need to see where the actual knockback's being applied. I completely forgot where that is. And I don't have a... Hold on. Is it physics.sig somewhere? No, I don't. It's in the system.sig. Where was our physics? I thought we had a physics system, right? Okay, where did I put it? Not game state. It's not game state, right? Game simulation. It's game simulation. That's right. So our physics system is the game simulation. As I remember, there's an action system. There's a physics system. Okay. Apply knockback, right? So this is kind of a ground knockback stuff, right? So we don't actually have a real kind of standard way of applying friction. We just reduce knockback over time. That's for the ground knockback. But for the air, we're not actually going to use the knockback. In fact, we're just going to apply a velocity. The reason that is just kind of historical, right? We could do a air knockback and have it kind of like slide backwards and stop. And maybe some games do have that. Maybe like Tekken or something has that, where they knock back and they slow down, so you can easily juggle. But in our game, again, because this is very common, we're not going to use that kind of like standard knockback that's done on the ground where they slow down. We're just going to let the character that received the hit keep flying. So we're not going to use knockback actually. So we have to go back to our, I think, reaction system and not apply that knockback when they're in the air. So right now we have hit stun, and knockback here, way down here, right? So we're not going to apply the knockback there. We're only going to apply knockback when they're not in the air. So that's something we have to do here. And I can just comment on that to make it clear what's going on. Oh, use the standard. Oh. Well, only use the knockback physics. Only use ground knockback physics for grounded attacks. Okay. Okay, and so in the air, instead of this, we have the, should we reuse the knockback thing for air physics? No, we're not gonna do that. We're just gonna make it separate. We're gonna say it's a separate property, right? So let's go here and change the game event, or hit event, right? Hit event. So we have launch velocity x, and that will be used as our air knockback velocity. Or you could say air knockback or something. Yeah, maybe it's more consistent with what we're thinking. Yeah, it's one of those things where you have a lot of choices, and I'm sorry to whiff waff between the two, but I'm thinking about juggling in the future. We can reuse this variable, right, for the knockback in the air. So I'm just going to call it air knockback for now. Okay, and let's go to our yeah, we actually have to go through here and add a new property here for reaction components. So let's just say air knockback 32 equals 0. Again, you see where I do a lot of repeating of myself when we kind of do these staged things where you have a hit event and those properties get applied to the character state. Maybe there's an ideal thing where you're not doing this, where it's like a separate struct for just storing the hit properties. But for now, yeah, I'll just do this. For simplicity's sake, though it leads to complexity, and then we compile simplicity on simplicity. Okay, back to our collision system, where we have our default hit property, right? We're going to Yeah, knockback, and we have launch velocity. Let's go do our air knockback. Yeah, I think it's called air knockback. Yeah, I don't know what we're gonna apply right now. Just where the value comes from. So right now we have a knockback like that. I'm just gonna apply the same speed, initial speed for now. So now that's there, and we can copy it over in our reaction system to the character's reaction component. Only when they're in the air, though. So similar to this, again, we could just reuse this knockback value, but maybe there's reasons to separate it in case the character got hit on the ground and was unable to be launched. Maybe you want to have that kind of situation. Who knows? Okay. So we got that. Now we have to apply it to the state itself. So common states. So I showed you that thing before where it's like set forward velocity. And the forward velocity is going to be the opposite. We're going to have to flip the value, right? Because we want to set the forward speed to negative. Okay, so a launch reaction will set our forward speed to, not the forward speed value there, but to the reaction component, right? Reaction component dot air knockback. And in theory, this should work, unless I forgot something. Then it won't work. But that's quite obvious, right? So, not, oh yeah, so exactly, I messed up, right? I should have made this negative. There we go. There we go. Okay. It's still like, it's hitting a wall and recovering. I wonder if that's because it's ending the state. Oh yeah, so it's not looping. The state's not looping. You see how it goes to jump and just falls when that state is ending? So we need to make this state looping, and I think we can do that within our character data, I think. Yeah, we have a looping. Okay. So let's go jump. No, not jump. Launch reaction. And the duration, let's just say is looping under, I think. I don't know actually where it is in the structure order-wise. Oh, I didn't kill the game, did I? Yeah, I need to reboot it. Okay, here we go. Okay, so now they shouldn't just like end. It should just go all the way until they get on the ground. Oh, nope, it didn't. It still ended. Why is that? What's going on? I said it is looping. Ah, I think because we have a specific check for that somewhere in our state system. So, where is it? Our common states. So our launch reaction, it updates. No, it's fine. We don't do anything specific there. Is looping. Let's look for is looping. Wow, we only have is looping here. What's going on? False there. If it's looping, we reset, right? So what did I do wrong? Test character is looping, right? That's correct. It's interesting. Also, I set the duration of launch reaction to 1,000, so it shouldn't have ended. What am I missing here? Hold on. Because yeah, definitely the duration should have been way longer than what was indicated here. What am I missing? Is it playing the normal reaction? It's playing the normal reaction length. So cause that's 100 frames. So actually something. Oh, wait. Is it the hit stun that's making things mess up? Do we still have the hit stun application? Maybe that's the case actually. Let's disable that real quick. I think that's in the reaction system. That's probably what's going on. Okay, I think we have a hit stun check. Yeah, so oh yeah, previously I said we want to, fix the bug as they come up, and this is the bug, right? So okay, we reduce hit stun. If hit stun less than 0, then we would go back to order. Let's say unless they're in the air. So if let's say game state dot reaction dot components dot, oh no, what am I doing? No. Oh no, okay. So I think it's reaction dot, if it's a launch, then do nothing. Can I do that in Zig? I forget if I could do that in Zig. Like, see, it might complain. Yeah, I didn't like that. Didn't like that at all. Or maybe that's the issue. Maybe that's the issue. Oh, I didn't copy over it being a launch attack or not, did I? Or wait, I forget. Attack has hit. Okay, yeah. So actually, instead of doing that, we're just gonna be lazy. I'm gonna be lazy. And well, we're not actually pulling the physics in right here. Yeah. Let me think how I want to do this. One way we could do it is just give it a lot of hit stun, right? Way more hit stun than you know what? We'll just go ahead and add support for air recovery right now. So we have to check whether or not in the air. The issue though right here is we're not actually pulling in the physics properties. We can do that by just I think game state dot reaction, not reaction components dot physics components, and we'll do entity index dot position dot y. If it's greater than 0, we know we're in the air according to our game rules, right? And then we won't go to oh, actually it doesn't really matter here because I think our common transitions just go back to if we go here, I think we go to air from the air. Yeah, that just works. So don't really have to worry about that at all, to be honest. So the only thing you have to do is make sure we have enough hits done to last. So yeah, so let's go to our collision system and add hits done to be very, very large. Let's just say like 1,000. And then it should just gonna work. Okay. Yep, it just works. And they go through the floor because we forgot to add the collision on the ground check. So jump has that. We can just copy it from jump. Handle ground collisions. So launch reaction on update. I think that's it, right? Nope. So we don't need this anymore. Goodbye. Default thing. Ooh, explicit default. Now we should be good. Now, in a real fighting game, we would have a like we would have a how do I put it? We'd have a different action to play when they land on the ground. They would actually probably land on the ground and have to wake up. But so far, we don't have any kind of like wake up actions in our game, so that we're just gonna have to put that off for now. And yeah, so we got our basic juggle here. Not even juggle, just launch. So I do want to show you how to juggle here as well, but I need to do the knockback less for now. So this is kind of nasty. We're hard coding all these hit properties still. I do need to add the hit property to the character data, which I wish I had done already. But it is, you know, sometimes you just forget stuff. And that's life. So let's just make the air knockback much smaller, like 2 or something, 2,000 units. How are we doing on we're doing good on time? I think we are. Got 15 minutes or so. So if there's any questions and stuff, because I think I'm gonna finish up what I want to do today here. And yeah, look, juggling just kind of works. Let's see. Are we getting the right reaction? Yep. So launch reaction works. The reason why it does work right now is because the attack just has the launch property, so they get launched every time. If we wanted like a special air hit state that's separate than what happens during a launch, there might be reasons to do that, right? You might have a different animation for the air hit versus the launch. Like maybe a launch looks like this, where the character gets knocked straight up, and maybe air hit looks like this, where they hit like at an angle, and they kind of fall like this. Sometimes like games, especially Street Fighter, will have a character going like, I'm gonna show you with the speaker here. They get like launched like this, and they curve around, they come down like this. But then you hit a character in the air, and they just get like kind of this angle like this, right? That's kind of the cool like nuanced stuff that happens in fighting games that I really want to cover eventually. I think after this kind of initial series of going around the basics of stuff, I might start getting into those details of like how do you handle all this animation related stuff, you know? Yeah, we have juggles. Yay. So that's pretty straightforward, I think, right? There's a lot of details here we didn't really get into, like how to implement the hit properties on character in the character data. Um, Maybe I'll do that next time as kind of an exercise. Like, you know, it's not that we know what to do. It's kind of straightforward, but we'll go ahead and implement that. Okay. Sweet. You know what? It was pretty quick to implement something like this, you know? Um, and honestly, because of what we've implemented before, it made this so much more easier. Yeah, it's a lot of moving pieces. And we haven't even gotten into animation. Like, character animation adds so many layers of complexity to this, right? For normal attacks, it's mostly fine, but when you get into these reactions that need to play specific range of, you know, maybe for a sprite-based game, it has to play a certain sequence of frames. It has to hold those frames a certain length of time, depending on the physics, right? Now you have like animation depending on physics. If we're talking about a 3D game, we might have like an animation graph with blending that chooses like which pose to hit depending on the physics properties. It's a lot of stuff. But yeah, I'll submit this so you guys. Oh, I need a special move. um, I'm trying to do the special cancel. Oof. Doesn't really matter. They have the same properties for now. All the hits have the same properties. Yeah. Let me just go through and see what my changes are. I have this. We touched a lot of systems today. Game state, component, collision. Yeah, cool. Oh, and the character properties. I want to forget that. Do. Okay. I might update the notes later. Okay, so I'm going to say supported launching attacks, launching reactions, launching attacks, a launch reaction, and juggling. Cool. So that's in there for people who want to test it and play around with it. Yeah. Let me check out your message here, Melly Mellon. Do you have a specific end goal of functionality you're hoping to reach with this project? Yeah, I just want to go over what I consider the basic functionality of fighting games. You know, minus animation. um, that's a complex topic and super nuanced, and I would have to get access to like either like a good set of copyright free art to really demonstrate it, or I would have to animate stuff myself, which is doable, but it's much easier if I have access to a 3D package. Um, I have access to Blender, of course, but I would have to export sprites and do all that kind of stuff. That's kind of annoying. And then I would only be showing how the stuff would work for sprites. There's so much knowledge that has to be applied for 3D animation that would be really useful as well. Maybe I'll have to do a thing where I run the game under Unreal or something, or Unity, and show it there. I think it's possible because Zig links really easily with C programs. So yeah, that would be cool, maybe. But that would be the end after this. I think we're getting close though, right? I think we're getting close to like a lot of the core functionality that's important to make a fighting game fun and balanceable. Maybe we'll do a stream here in the future where I'm talking about all the potential things that we could cover. You know, I know there's like all these little details that I've mentioned. I was like, oh, we could do this, or we could do that. This would make things better. Like we haven't got to projectiles yet. I think that's something I do want to cover. Yeah, Melly Melon's asking about why 2D animation would be complex. Well, again, it's going to be complex in similar ways, where you're not just playing a fixed sequence of sprites, where each sprite is maybe holding on screen for a fixed amount of time. all the time, right? When would that happen? Well, it mostly happens during reactions. You have hit stun, right? Hit stun can be any value, uh, depending on what the attack was set up as, right? Attacks have their own hit properties that are different. You can conceivably like make 100 different versions of of a hit reaction and manually like set up those the lengths of those animations, but it's kind of weird to be doing that, and it's a lot of unnecessary work. So you typically what you do is you kind of have rules of when to change the sprite during hit stun. So maybe you have like the initial pose will be stuck like here, depending on the strength of the attack. Maybe stronger attacks will go really far, kind of a hit reel, and then you'll maybe fix or loop a pose or something until hit stun is under a certain value. And when you have, let's say, like, I don't know, 10 frames of hit stun left, then you play out like a fixed 10 frame animation at the end to kind of return to idle. It depends on the game. What I'm describing is really closer to like Street Fighter does. Probably other games do things differently. And you would do something similar in 3D as well, typically. Now, if you're talking about like an action game, a lot of action games just have a fixed reaction, right? That they always just go through. But I think eventually you do want to have the ability to adjust hit stun just so you can control how long enemies are stuck in that reaction. Just for balance sake and feel, Yeah, any other questions about this stuff for y'all out there? I think I'm ending a little early today, but we did cover quite a bit. I know that maybe not a lot of code, but it seems like I said before, all the initial work we've done up to now lets us kind of like quickly get to our it lets us like implement a new feature like this pretty quickly, because all that initial infrastructure is there. One infrastructure like having hit properties, which we don't have yet on character actions. We have to go through and add that in the in the JSON file. I'll probably do that next time. It's going to make things much easier. And honestly, I do kind of want to fix the problem of all this like boilerplate for for states, for action states. Oh, apologize for my stretching and yawning here. Well, cool, y'all. I know it's a little bit later than normal, so it might be a little bit too late for some of y'all working tomorrow out on the East Coast, but thanks for coming by, and yeah, I hope you all can come by and watch the next stream, or future streams. As always, I'll put this up on the YouTube archive on the Zig Fighting Game playlist. Should be in a few hours, depending on the processing time. So, yep. Well, that was it. Until next time, have a good one. Hope you guys, good night, good morning, wherever you may be. Till then, peace.